Beloved learners, welcome once again. My name is Mr. Paul Chilola, your teacher on this very platform. This is Black Slides Online Secondary School YouTube channel. It is on this platform only where you learn the sciences for free, including mathematics. But if you want private tuition, you can also consider to enroll for a private tuition. All you have to do is contact me on the number shown here. Just send me a message expressing your interest to enroll for private tuition, whereby upon paying a small fee, the very small fee of 15,000 kwacha a month, you'll be added to a Google Classroom where you meet other students, and then you learn all the subjects there. A full MSc is being offered there. So all you have to do is contact me on the number shown here, or you can also contact me on the number 098 125 1258 and then 577. Yeah, so these are the two numbers on which you can get in touch with me if you need extra tuition. Apart from learning here on YouTube, you can also request that you be added to a Google Classroom where you have access to all the subjects there at a very small fee of 15,000 kwacha. All right, so once again, welcome. My name is Mr. Paul Chilola. If you are new to the channel, consider subscribing to the channel. Subscribe to the channel and hit the notification bell so that every time a new video lesson is uploaded, you are notified right on time, so that you can access the lesson. All right. So, but let me clarify here that as long as you are learning here on YouTube, it is totally for free. Access to lessons on the YouTube channel, this YouTube channel, is entirely for free. You don't need to pay anything in order to access lessons on YouTube. All right, so welcome to the topic called the more, where we are going to look at formulae of compounds, chemical equations, and other aspects. By the way, this topic falls under a broad topic called stoichiometry. Stoichiometry. All right. So welcome to stoichiometry. This is a Form 3 topic, MSCE topic. But those doing other curricula such as Cambridge can also benefit from the same topic, from learning the same topic, because the Cambridge curriculum also has this topic on offer. So welcome all to the lesson, to the introduction of this topic, stoichiometry. All right, so what is it that I intend to cover with you in this topic? The specific objectives. All right, so by the end of this topic, you, the learner, should be able to do these things You should be able to give the definition of the mole. Define the term mole. Alright. Relate the mole to what we call relative atomic mass. Convert, this should be convert, not convert, but convert mass into moles, and vice versa. You should be able to convert mass into moles and vice versa. You should be able to determine the empirical formula. Don't worry about these terms, they're going to get clear as we go. Determine the empirical formula as well as the molecular formula of compounds from experimental results given data. Explain the terms concentration, molarity, and dilution of a solution, and then define molar solution. Right, so these are the things that you should be able to do once you finish the topic. Alright, more objectives. You should be able to prepare molar solutions. You should be able to carry out titrations and calculations involving molar solutions. You should be able to write correct full formula of and ionic equations of reactions with state symbols. State symbols refer to symbols like gas, G for gas, L for liquid, aqueous, AQ, and the solid, S. Alright, you should be able to define molar gas volume and the atomicity of gases. You should be able to state Avogadro's and the Lucas laws and carry out related calculations. Alright, so to take note, these are just objectives of the topic called stoichiometry. Alright. Okay, I hope so far so good. Once again, in case you have just joined the channel today, my name is Mr. Stoichiometry, the teacher on this platform, and I'm excited to have you as my student. Alright, so let's look at the main content of the topic. So we are going to look at the mole as the basic unit. Alright. The mole as basic unit, molar mass, relative atomic mass, reference to carbon-12. The mole as the number of particles, and we are going to illustrate using counting by weighing experiments. Conversion of mass in grams to moles, and vice versa, where we consider atoms, molecules, and the compounds. So this is the main content that you're going to cover in the topic. Alright, that's great. I hope you are good. Alright, more content. We are going to look at determination of formulae, empirical and molecular formulae, quantitative determination of composition of magnesium oxide, copper oxide. Then we are going to look at molar solutions, preparation of molar solutions, molarity of solution, concentration and dilution, stoichiometry of chemical reactions, use of ionic and full formula equations in calculations of reacting quantities. Then we go on to look at molar gas volume and atomicity of gases, Avogadro's and the Lucas law and the related calculations. These are just the areas that we are going to deal with in this topic. Alright, so let's look at a brief introduction of the topic, what we'll be dealing with. The mole, formula and chemical equations. Alright, some introduction. The mole as a basic unit is simply a chemical counting unit. We are saying the mole is just the counting unit in chemistry. All right? Just like you are able to count eggs. You count eggs, put them in groups of 12, you have dozens of eggs. If you have 20 eggs, you have a score of eggs. If you have 144 eggs, then you have what is called a gross of eggs. Okay, so a mole is the basic unit, is the counting unit in chemistry. The symbol for a mole is MOL, which is the shortened form of a mole or moles. So in order to establish a counting unit, chemists have found it convenient to express the mass of any atom relative to that of a chosen element. Thus, a mole is the amount of substance which contains as many particulate entities as there are carbon atoms in 0.012 kg or 12 grams. So we are saying a mass is the amount of substance which contains the same number of particles as carbon, 12 grams of carbon 12. Remember that we have three forms of carbon. We have carbon 12, carbon 13, and carbon 14. So the one we use as a reference for comparison with a mole is carbon 12. So take 12 grams of carbon 12. The number of particles it contains is similar to the number of particles that are contained in 1 mole of any substance. So take note, we are saying that definition of a mole one more time. All right, so we're saying a mole is the amount of substance which contains as many particulate entities as there are carbon atoms in 12 grams of carbon 12. All right, so what are these entities that we are referring to? What are these entities? The entities we are referring to, in this case we are saying it contains as many particulate entities as there are carbon atoms in 12 grams of carbon. So these entities can be atoms, these can be atoms, can be molecules, can be ions. By entities we mean these particles. It can also be in form of what we call radicals. All right, so once again, they may ask you to define, your examiners can ask you to define a mole. What is a mole? So we are saying a mole, what is a mole? Define a mole. All right, so a mole is the amount of a substance which contains as many particulate entities as there are carbon atoms in 12 grams of carbon. 12 grams of carbon 12. All right, so we are looking at how many particles or how many atoms are in carbon 12 of carbon 12 grams of carbon 12. That number of particles is equivalent to a mole. All right, so we compare the number of particles contained in 12 grams of carbon 12 with the number of particles that can exist in any other substance. All right, so that's very, very important. Okay, I hope we captured the definition of a mole. Another term also worth defining is what is called relative mass. What is relative mass? Relative mass, all right, relative mass is when the mass of any atom is compared to that of another, it is referred to as a relative atomic mass. So In the past, hydrogen was chosen as the reference scale because it has the lightest element. Mass of hydrogen atom was given an arbitrary value of 1 atomic mass unit, written as 1 AMU. The masses of all other atoms were then measured relative to hydrogen as follows. So relative atomic mass was defined as average mass of one atom of any element divided by mass of one atom of hydrogen. So mass of one atom of hydrogen is just 1. That means the relative atomic mass would simply be equal to the mass, the average mass of that particular element, because any number divided by 1 is equal to the same number. So on this scale, for example, sodium atom is 23 times heavier than the mass of hydrogen atom. Therefore, the relative atomic mass of sodium is 23, because 23 divided by 1 is just 23. All right, so this was in the past, but later, with the progression of chemical knowledge, in the early 20th century, the hydrogen scale was replaced by oxygen scale due to the problems caused by the presence of isotopes of hydrogen. Hydrogen exists in a number of forms, like we have hydrogen 1, hydrogen 2, and hydrogen 3. So that variation in mass has caused huge problems when it comes to determination of relative atomic masses based on the hydrogen scale. It was later discovered that the oxygen scale led to problems due to existence of oxygen isotopes. Hence, in 1961, an organization belonging to the United Nations, which is called International Union of Pure and Applied Chemists, recommended a new scale based on the carbon-12 scale isotope. So carbon-12 was taken as the reference because it is solid, stable, and it is a very common element. On this scale, an atom of carbon is assigned a value of exactly 12.000 AMU. Thus today, relative atomic mass of an element is defined in the following manner: as the average mass of one atom of the element divided by 1/12 of the mass of one atom of carbon-12. All right. So if you look at this, this is the same as dividing by 1. Dividing 1, because we are looking at 1/12 of 12 grams. All right, or 12 AMU. It's the same as dividing by 1. Therefore, the relative atomic mass of an element such as sodium, remember, is 23. One atom of sodium has 23 grams. Therefore, its relative atomic mass will be 23 grams divided by 1/12 of 12 grams, which is the same as 23 grams divided by 1, which is just equal to 23. All right. I'm sure this will get clear as we go along. In case you have just joined the channel, you have just visited the channel for the first time, my name is Mr. Pochilola once again, your teacher on this platform. All right. So since RAM is a ratio and it has no units, so we are saying RAM, relative atomic mass, has no units. It's just a pure number. All right. Then we have a very useful constant here, which is called Avogadro's constant, written as L subscript A. Avogadro constant is the number of atoms or molecules, which are particles, or it can be ions also, in 1 mole of a substance. It has been established that the number of atoms in 1 gram in grams of any element is 6.023 times 10 to the power 23. The number is named after Amedeo Avogadro, an Italian physicist who lived in the years 1776 to 1856. Therefore, the amount of any substance that contains Avogadro's number of particles is called 1 mole. It is a standard counting unit. A mole contains 6.023 times 10 to the power 23 particles. Like I mentioned before, these particles can be atoms, molecules, ions, electrons, etc. So the mass in grams of 1 mole of a substance is referred to molar mass. So take note, we are saying that 1 mole of any substance is simply equal to the number of particles equals to 6.023 times 10 to the power 23. This is quite an enormous number. It's a very big number. So if there are this number of particles in a sample, then it means you are talking about a mole. You are talking about a mole. So take note, we are saying that what we call a mole of anything is simply this number. Just like you would say a dozen of eggs is 12 eggs. So a mole of atoms is 6.023 times 10 to the power 23 particles. And the particles can be atoms, molecules, ions, electrons, or any other counting units in chemistry, or any other elementary particles or entities. Very important. So, therefore, this number is called Avogadro's constant. It's called Avogadro's constant. So, let's just say we have 1 mole of carbon. When you say 1 mole of carbon atoms, 1 mole of carbon atoms, it means you are looking at the number of carbon atoms equals to 6.023 multiplied by 10 to the power 23 atoms. I hope you're getting me there. 1 mole of carbon atoms is simply this number of atoms, 6.023 times 10 to the power 23 atoms. Okay, so half mole, therefore, it will be half of the same number. Quarter mole will be 1/4 of the same number, and so on. 2 moles shall mean twice as much as this number. So this number multiplied by 2 shall constitute 2 moles of the same substance. Once again, my name is Mr. Pochilola. Remember to contact us if in case you need extra help. It will be a pleasure for me to help you separately by giving you extra direction how you can make it in sciences, pass the sciences very, very well. All right, so let's relate what we discussed to this work. All right, state the particulate entities in the following cases. Hydrogen gas, you know that hydrogen is diatomic, written as H2. Therefore, the entities will be molecules. It's more appropriate to say hydrogen gas molecules than hydrogen gas atoms, because you cannot find hydrogen gas existing as a single atom like this. No. All right. Sodium chloride solid. You shall have sodium ions and chloride ions. All right. Sodium chloride is NaCl. So this being an ionic compound, it means it has sodium ions and chloride ions. Therefore, it is more appropriate to refer to sodium chloride in terms of what the ions it contains. In this case, we have sodium ions and chloride ions. All right, so from our definition of a mole, that means in sodium, if we have 6.023 times 10 to the power 23 sodium ions, then it means we have 1 mole of sodium ions. All right. Similarly, if we have 6.023 times 10 to the power 23 chloride ions, we also have a mole. 1 mole is just this number. Don't get confused. 1 mole of something is this number, 6.023 times 10 to the power 23. That's what we are saying there. All right. Glucose is a molecular substance, so it is more convenient to refer to glucose as glucose molecules. Glucose molecules. Glucose is C6H12O6. All right, so 1 mole of this shall mean that you have 6.023 times 10 to the power 23 of these. That's 1 mole, okay? That's 1 mole. All right, so 1 mole is simply equal to 6 times 10 to the power 6.023 times 10 to the power 23. Great. Question number 4. You are provided with 0.5 mole of hydrogen gas. Work out the number of moles, the number of hydrogen molecules. All right. Okay. Hydrogen atoms. Okay. So remember that 1 mole, if 1 mole of hydrogen contains 6 times 10, 6.023 times 10 to the power 23 molecules. Therefore, 0.5 shall mean dividing this by 2, or just take half of this, or just take 0.5 times 6.02 times 10, 6.023 times 10 to the power 23. Just multiply 0.5, it will give you this number of molecules. So 1 hydrogen molecule contains 2 hydrogen atoms. Therefore, this number of molecules, you just multiply this by 2. Remember that hydrogen is diatomic, so 2 atoms make 1 molecule. Okay? So there are 2 atoms in 1 molecule. All right, so we are saying in order to get the number of atoms, just take the number of molecules multiplied by 2. I hope we are together there. So listen carefully. All right. If I can take you back again, the question is saying you are provided with 0.5. 0.5 is the same as half hydrogen gas. All right. Work out the number of hydrogen molecules. So we are saying 1 mole is equal to 6.023 times 10 to the power 23 molecules. All right, that's what we are saying. So what would you say about 0.5? 0.5 moles. So all you have to do is take 0.5 moles, divide by 1 mole, and then you multiply by this number. It is going to give you the number of molecules in half mole, 0.5 moles. Right, so whatever number of molecules you get, remember that 1 molecule is H2. What about 2 molecules? Okay, 1 molecule, so let me say that again. 1 molecule of hydrogen has 2 atoms. All right? So, in 0.5 moles, we have this number of molecules. That means the number of atoms. For us to find the number of hydrogen atoms, you just take the number of molecules multiplied by 2. So you get this number of atoms there. All right, so far so good. I hope we were together there. In case you have questions, don't hesitate to invite me to respond to the questions. I'll be very glad to rectify anything that I might not have explained properly. My name is Mr. Stoichiometry once again, wishing you a beautiful working experience. Right. So, questions for you to do and you give me the answers for. You are given 6.02 times 10 to the power 23 molecules of water. Calculate the amount of moles in water. All right. Calculate the number of moles. Remember that one mole is equal to 6.023 times 10 to the power 23 molecules. All right. Okay. So that means here, in calculating the number of moles, you wouldn't even have to show any working because you are told already that you are given the Avogadro number here. The Avogadro number is equal to 1 mole. That means here is 1 mole. The number of moles of hydrogen atoms. All right. So one molecule of water has 2 hydrogen atoms. All right. So what about this number of moles? So to find the number of, remember these are molecules, the number of hydrogen atoms, just multiply by 2. So you simply multiply the 6, you multiply the 6 by 6 point, you multiply the 6.023 times 20 times 10 to the power 23 by 2. It will give you the number of hydrogen atoms. All right. Remember also that the ratio of hydrogen to oxygen in water is 2 to 1, meaning that for every 2 hydrogen atoms there is 1 oxygen atom. That means the number of oxygen atoms is simply equal to the number of molecules. So in this case, the number of oxygen atoms is still going to be 6.023 times 10 to the power 23 oxygen atoms. All right. So that's basically what you were supposed to have done. Please go through this example again and again until you are convinced that you can handle this on your own. Once again, my name is Mr. Stoichiometry, wishing you a beautiful night as you continue learning from this channel. Remember also to invite your friends everywhere they are so that they can join you. My name once again is Mr. Stoichiometry. Kindly subscribe to the channel so that every time I upload a video, you are not left behind.